Hi folks, I'm Charles. In this video, we're gonna do a centrifugal compressor design with Vista CCD and BladeGen, and then do the meshing with TurboGrid. Let's start with centrifugal compressor design, Vista CCD. What you will do is plug in all the numbers from our preliminary design file, and then just click calculate. It will generate a one-dimensional design for you. And then you can create new BladeGen to get the 3D design file. Once you have the 3D design file, you can transfer data to new TurboGrid and update the TurboGrid. Then you will have a mesh ready for use in CFD. It's gonna take some time. Let's check the progress. Okay. While we're waiting, let's talk about diffusers. So the diffuser matching is uh, diffuser matching with the impeller is a big topic. So it should be included in the preliminary design file. For now, the turbo grid is finished. So the impeller is done. Now let's do the diffuser. For now, we don't have that preliminary design diffuser. So let's just create a random one in the with BladeGen. So this is the kind of menu that you will get when you are starting a new design. All the numbers, they should match your design requirement. For example, the inlet coordinates should match what you have in the BladeGen in the impeller design. For example, here we have the coordinates, segment operation, point location, this negative 40 something. Okay, and let's get the new BladeGen. That would be negative 4 point something. Also the outlet angle. Segment operation 62. So yes, you do want some distance between the inlet and outlet because this is the blade height. It will have some inlet areas that doesn't have the blade. So let's say 70 is okay. Actually, I'll make it 75. Okay. Radio diffuser is down. 11 blade. That looks okay. Blah, blah, blah. Okay. Now let's match the outlet file, inlet coordinates again. Point location 62. Okay. Here, point location. Okay. Now I seem to have dragged that coordinates by mistake. Let's put it back in. Okay. Now we have the 3D design file. Everything looks not bad. Cool. Now let's do the same thing. Transfer data to new TurboGrid and mesh the file. So once this is done, you've done modeling the blades and also generating the mesh. It's throw us an error. Basically says the half dimension is seriously wrong. Also, same thing goes for the short dimension. That's because if you started a design with BladeGen, by default, the unit is unknown, and it freaks out TurboGrid. So now let's set it to millimeters. And it should solve the problem. Also, since we're on this topic, we actually do want to check the direction, rotational direction of the impeller and the diffuser. For example, right now, the impeller, let's say it's rotating with, looking from this direction, let's say it's rotating with in the counterclockwise direction. And as you can see, the diffuser is at the wrong location, so we need to flip the diffuser as well. No. First rotation directions. Yes, okay. And now those numbers should match. Perfect. And let's update TurboGrid. Should solve the problem. So now it's finished. Everything looks fine. Then if you are using the CFX or workflow, you can transfer data to new CFX. Same thing, you can drag the model here to set up and then do the CFX workflow, no problem. If you are doing the Fluent workflow, you'll realize that there is a Fluent option there, but you cannot really drag the second mesh file in there. Plus, Fluent really hates Workbench. At least for the version we're using, there is a huge connection issue, let's say, between Workbench and Fluent. So if you're using Fluent, what you will need to do is you want to actually export the mesh file from TurboGrid and then launch Fluent as a standalone application and import the mesh file into Fluent. Let's demonstrate that. Export meshes. Now it's in a temporary folder, which will make it a little bit problematic. So let's first save the entire Workbench file. And let's call it the date 75. Okay, the Workbench file is saved. Now let's start TurboGrid again. Sync a little bit. And then export meshes. Normally you can save it to the user files folder so that it will be separated from the rest of the Fluent system. Let's give it a meaningful file name. This is diffuser, and the recommended file format is GTM or DEF. Right now, let's use GTM. You want to check the file type is CFX. Exporting meter is meter. Units is meters. Combining one domain, one files, and everything else looks good. So let's save. Okay, now we have the mesh file for the diffuser. And same thing for the impeller. And export meshes, impeller.gtm. And now you're ready to run your simulation.